Algebra I 11.1b, real numbers, rational versus irrational. So each rational number can be found at one point on a number line. But there's many points on a number line that are not rational numbers, and these points indicate irrational numbers. Every point on a number line is either a rational or irrational number. Combined together, they all make up the set of real numbers. I forgot my y here, didn't I? So altogether, the rational and irrational numbers, those are all the real numbers, okay? And real numbers consist of all the rational and irrational numbers, all right? Any rational number can be written as a fraction, like a over b, where a and b are integers, positive and negative numbers, as long as b doesn't equal a 0. Rational numbers written in decimal notation either end or continue to repeat the same digit. So 1/4 can be written as 0.25, and that's rational. And 1/3 can be written as 0.333, and that 3 just keeps repeating, doesn't it? So that's rational. And 5/11 is equal to 0.45, and the 45 keeps repeating. See? So it would be 0.454545. So we just put a bar over the 45 to show that it repeats, right? An irrational number can't be expressed as a ratio of two integers. That means it can't be written as a fraction of two positive numbers or two negative numbers. When irrational numbers are written in decimal notation, they never end or repeat their digits, ever. So pi is irrational. There's 13.3 trillion digits that have been found for pi as of July of 2016. That's an extremely irrational number. So pi is irrational, and also the square root of 2. We can approximate pi as 3.14 when we do math. We just make sure we have to use that approximate symbol, right? We don't use an equal sign, we use the approximate symbol. We can also use 22 over 7 when we have it in fractional notation. So when we're doing square roots and we're looking for squares and whether they're rational or irrational, 1/13 is rational because it's written as a fraction. But the square root of 13 is irrational because whatever the square root of 13 is cannot be written as a fraction. A number is irrational if it's not a perfect square. So take a look at these. 25, the square root of 25 is rational because it's 5. 5 times 5 is 25. See that? The square root of 13 is not because we can't find a perfect square for 13. And I tried. I did 3.6 times 3.6, and I got close to 13. I tried 3.605 times 3.605. I still got close to 13. And I tried 3.61, and I went over 13, so I have to keep playing around with that to try to find it. But it's irrational. And the square root of 1.44 is rational, and 1.44 is rational. Because 1.2 times 1.2 makes 1.44. See that? The square root of 4.7089 is rational, and 4.7089 is rational. Because 2.17 times 2.17 makes 4.7089. 2, the square root of 2 is irrational. If we look for a number, some number a over b, that's going to equal 2 when we square it, we can find rational numbers that have squares that get really close to 2, but we can't find one whose square is exactly 2. Sort of like what I was doing with the square root of 13. I can get close, but I can't get exact. So the square root of 2 is irrational. And the square roots of most whole numbers are irrational. Only the perfect squares have rational square roots. So 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. See? Those are perfect squares, and they have rational square roots. We can identify rational and irrational numbers by whether they have a perfect square or not, or if they can be written as a ratio, expressed as a ratio of two integers. Can they be written as a fraction, positive or negative? Remember that little 0? The square of 0 is 0, and he's rational because of that. Our next video, 11.1c, we're going to talk about approximating irrational numbers, like trying to approximate what the square root of 2 is or the square root of 7. And this is really important. The entire first chapter of my grade 8 math playlist talks all about this. And I'm going to have links to the irrational numbers, estimating their value. That was video 1.1d. And comparing irrational numbers. And the Algebra I from this playlist, Terminating and Repeating Decimals and Irrational Numbers, was Chapter 2, 2.6f. And we did our previous video, Square Roots and Principal Square Roots, that we did just before this one. And I'm even going to have one about classifying numbers with sets and subsets of numbers. That was from Chapter 1 of Grade 8 Math. The whole Chapter 1 of my Grade 8 Math playlist would be really good to review right now, all right? Before we start getting into the radicals and radicands and stuff, all right? So I'll see you next video. I hope this was helpful. I hope you're really doing okay. Keep trying. We're going to make it through this. We're almost done. We've only got a couple more chapters to go, and we're going to be finished with Algebra I. Bye.